In this question, we are going to look at how to balance a redox reaction in an acidic medium. Before we start, let's first find out the oxidation states for each of the chemical species so that we know which reaction is the oxidation reaction and which is the reduction reaction. So for Fe2+, Fe3+, and Mn2+, the oxidation state is very easy to find because these are monoatomic ions. So the oxidation state will be equal to the charge on the ion. So for Fe2+, oxidation state will be +2. Fe3+, oxidation state of Fe is +3. And for Mn2+, the oxidation state of Mn would be +2. For MnO4-, we'll have to calculate the oxidation state of Mn. So let's say for Mn, since we don't know the oxidation state, let's write it as X. For oxygen, the oxidation state is -2, and there are 4 oxygens, so X plus 4 times -2 equals to the total charge of the ion, and that's -1 for MnO4-. So from there, we can calculate that X equals to +7. So let's write the oxidation state of Mn over here, +7. So based on the oxidation states, we can tell that Fe2+ was oxidized to Fe3+, so this is an oxidation reaction, whereas for MnO4-, it was reduced to Mn2+. So let's start by writing the half reaction for the oxidation reaction. We have Fe2+ as a reactant, and we have Fe3+ as a product. Let's first check whether the atoms are balanced on both sides. So on both sides, there is one Fe atom, so that's already balanced. There are no oxygen or hydrogen atoms to balance, so we just have to balance by adding the electrons. And we can do this by calculating the number of charges on both sides. So on the left hand side, we can see that the total charge is 2, whereas on the right hand side, the total charge is 3. So we need to make the total charges on both sides the same, and we can do this by adding electrons. Each electron has a negative charge, so by adding 1 electron to the right hand side, we will change the total charge to 2. So now the total charge on both sides would be the same. Okay, so this is our oxidation half reaction. Now let's look at the reduction half reaction. For our reduction half reaction, we have MnO4- as a reactant, and we have Mn2+ as a product. So for our first step, we need to make sure that the atoms on both sides are balanced apart from O and H. So for the Mn atom, it's already balanced. On both sides, we have 1 Mn. Now let's look at the other atoms. So we have 4 oxygen atoms on the left hand side. So we need to add 4 oxygen atoms on the right hand side also, but we do this by adding H2O. So to add 4 oxygen atoms on the right hand side, we will add 4 H2O molecules. Now that we have 4 H2O molecules on the right hand side, we need to balance the hydrogens by adding H+ on the left hand side. And since we have 8 hydrogens on the right hand side, we also need to have 8 hydrogens on the left hand side by adding 8 H+. So finally, we need to add the electrons. First of all, let's calculate the total charges on both sides of the equation. On the left hand side, we have -1 from MnO4- and 8 times +1 from the H+. So our total charge is +7 on the left hand side. Now let's look at the right hand side. You have a charge of +2 from Mn2 plus and nothing from H2O. So the total charge is +2. So to balance out the charges, we can add 5 electrons to the left hand side. This will add a charge of -5 because of the 5 electrons and change the total charge to +2. So now we have the same total charge on both sides of the equation. Finally, we want to add the two half equations together. But before we can add them together, we must make sure that they have the same number of electrons. The number of electrons given out by the oxidation reaction must be the same number of electrons taken in by the reduction reaction. So if we look at the oxidation reaction, right now we have 1 electron that's being given out, and in the reduction equation there's 5 electrons that's being taken up. So to make both of them have the same number of electrons, we will need to take the oxidation reaction and multiply it by a coefficient of 5. So we will have 5 Fe2 plus converted to 5 Fe3 plus and 5 electrons. So now we can add up these two reactions together to get our final balance equation. Take note that we do not need to copy over the electrons because the electrons will cancel each other out. So let's copy all the reactants onto the reactant side of the equation. We have MnO4 minus, 8H plus, and 5 Fe2 plus. And for the products, we have Mn2 plus, 4H2O, and 5 Fe3 plus. Finally, we'll just check to make sure that there's no chemical species that are duplicated on both sides of the equation. So now, since there's no duplication, we are done with this question, and that's how you would balance an equation for a redox reaction in an acidic medium.